Welcome to Quality Code, and today we'll be taking a look at the minimum domino rotation problem. It's a very popular Google interview question. So essentially you're given a bunch of dominoes represented by two arrays. A array represents the top row of the dominoes, and the B array represents the bottom row of the dominoes. So if we take a look at this example over here, as you can see, the top elements are 2, 1, 2, and A represents 2, 1, 2, etc. And the bottom elements are 5, 2, 6, right? So 5, 2, 6. And our job is to return the minimum number of rotations so that all the values in A are the same, or all the values in row B are the same. So if we take a look again at example 1, we can turn domino number 2 and 3 so that all the values in the top row are equal to the value of 2. Similarly, we could have rotated the first domino and the third and the fourth and the fifth so that all the values at the bottom row would have been equal to 2, but obviously that would be more rotations instead of just turning 2 dominoes so that all the top values are equal to 2. So the way our algorithm is going to work is following exactly what the question is asking us for. So what we're going to do is we're going to take the first value in A, which is 2, right? And we're going to see if we can make all the values in A in the top row equal to 2. And we're going to count the number of rotations necessary to do that. Similarly, we also need to count the number of rotations to make all the bottom values equal to 2. Since we could have an example where everything in the bottom row is equal to 2, except for the first domino. In that case, our solution would be a single rotation, which would be rotating the first domino so that everything on the bottom row is equal to 2. Now, if we can't make the top row equal to 2, then that also means we can't make the bottom row equal to 2. Because if we could make the top, then we could just rotate every single domino, and that would make the bottom row equal to 2. So that means 2 has been eliminated as a possible value. And so next we try with 5. Can we make the bottom or top row equal to 5? If we can't, then we have no solution, and we simply return -1. So this is a function we're going to use to count the number of minimum rotations necessary to make either the top row or the bottom row equal to target. So in this case, count top represents the number of rotations necessary so that the top row is equal to target. Count bottom is the number of rotations necessary so that the bottom row is equal to target. And n is simply the length of our array. We begin by looping through each domino. Now, if A of I is not equal to target, as well as B of I, then definitely we know we don't have a solution given the target, because at each index we need either A of I or B of I to be equal to target. If we don't execute this if statement, then we definitely know that either A of I or B of I, or maybe even both, are equal to target. So next we check if A of I is not equal to target. If it's not, then we need to rotate the domino so that the top value is now equal to the bottom value. That means we increase the value of count top. Similarly, if A of I is equal to target, meaning we don't execute this if statement, we need to check whether B of I is not equal to target. The reason for this is it's possible that both A of I and B of I are both equal to target, so we still need to check and make sure that B of I is not equal to target. Otherwise, if they both are equal, then there's no need to increase either count top or count bottom. Finally, we return the minimum of both count bot and count top, which is the minimum number of rotations to make either the top row or the bottom row equal. We now have everything to calculate our solution. First, we check if A of 0 is equal to B of 0. If they are equal, then we definitely know that count of A of 0 is going to be equal to count of B of 0, so we simply return count of A of 0. If they're not equal, then we return math of max of count of A of 0 and count of B of 0. The reason this final line works is because if count of A is -1, for example, then it would clearly be the max of both values. But what if, for example, count of A is equal to 5 and count of B is equal to 6? Would we still return the max value? The thing is, that condition is not possible. If it is indeed possible to make both domino rows equal, right, so let's say making the top row equal to 2 and the bottom row equal to 5, then the minimum to get the top row must also be the minimum to get the bottom row. So since they're equal, max is always going to return the correct value. Try to think about that a bit more to convince yourself, and thanks for watching.